Every second, something around you is moving. A car racing down the street, a basketball spinning through the air, or the Earth itself orbiting the sun at 30 kilometers per second. But have you ever stopped to ask how all this motion actually happens? How does a car go from 0 to 100 in seconds? Why does a ball eventually stop rolling? And what really happens when you jump, run, or throw something into the air? In this video, we're going to uncover the hidden science behind every move you make, the world of motion. You'll learn how physicists measure speed, describe direction, and predict how things move using the language of kinematics. By the end, you won't just see motion, you'll understand it. So buckle up, because once we start, there's no standing still. Everything around us is moving. Cars on the road, planets around the sun, even the atoms inside your body. In this lesson, we'll explore the first big topic in physics, motion, how objects move, how fast they move, and what affects their motion. By the end of this video, you'll be able to describe motion using scientific language, graphs, and equations, just like real physicists do. Motion simply means a change in position of an object over time. But motion can be described in two different ways. Uniform motion, when an object moves in a straight line at a constant speed. Non-uniform motion, when its speed or direction changes, that's what we call acceleration. Almost everything in daily life shows non-uniform motion, like a roller coaster or a car stopping at a traffic light. To describe motion, we use quantities called scalars and vectors. A scalar has only size, for example, a car moving at 60 kilometers per hour. A vector has both size and direction, like 60 kilometers per hour east. Distance is scalar, while displacement, the straight line change in position, is a vector. Speed tells us how fast something is moving, but velocity tells us how fast and in what direction. Average speed equals total distance divided by total time. Average velocity equals total displacement divided by total time. If you run a lap around a track and end where you started, your distance isn't zero, but your displacement and your average velocity are. Acceleration is the rate of change of velocity, how quickly an object speeds up, slows down, or changes direction. On a velocity time graph, the slope of the line shows the acceleration. A horizontal line means constant velocity. A positive slope means speeding up. A negative slope means slowing down. The area under the line represents displacement, the total change in position. When acceleration is constant, we can use 4 kinematic equations to solve motion problems. V final equals V initial plus acceleration times time. Displacement equals initial velocity times time plus 1/2 acceleration times time squared. V final squared equals V initial squared plus 2 times acceleration times displacement. Displacement equals the average of the initial and final velocities multiplied by time. These equations connect velocity, acceleration, time, and displacement, and you'll use them a lot throughout physics. When objects fall freely near Earth's surface, they accelerate due to gravity at 9.8 meters per second squared downward. That means every second their velocity changes by 9.8 meters per second. If we ignore air resistance, all objects, heavy or light, fall at the same rate. A special type of motion is projectile motion, when an object is thrown into the air. It moves in 2 directions at once, horizontally and vertically. The horizontal motion has constant velocity, while the vertical motion accelerates downward due to gravity. The path it follows is curved, called a parabola. At the top, its upward velocity becomes 0 for a moment before it begins to fall. By combining graphs and equations, we can analyze any motion, how far something moved, how fast it accelerated, and how long it took to stop or return to rest. Engineers use these same ideas to design cars, roller coasters, and even video game animations, where every jump or crash follows the laws of kinematics. So to recap, motion is the foundation of physics. We described how to measure it, graph it, and calculate it using displacement, velocity, and acceleration. Whether you're studying a speeding car, a falling object, or a soaring rocket, the same principles of kinematics apply. Thanks for watching, and get ready for our next lesson, Forces and Newton's Laws. Before you go, make sure to hit that like button and subscribe to our channel. Your support inspires us to create even more fun, engaging, and easy to understand educational videos just for you.